researcher any characterization labs which contain the reservoir solvent reservoir part with one quaternary pump is there, and this is a sampler or sampling unit. And here the different type of detectors are used for the detection of the separation. And in this machine UV visible detector is installed, and which is directly connected to the recorder, which is nothing but your computer. This is the a more clear view of your HPLC like this. Then we have, and this is another HPLC instrument with the ultraviolet detector is there. Then in introduction part we have, this is originally referred to as high pressure liquid chromatography, now more commonly called high performance liquid chromatography. HPLC is really the automation of traditional liquid chromatography under condition which provide for enhanced separation during shorter period of time. That means here the time consumption is less, and there is speed separation or fast separation is seen with respect to the traditional liquid chromatography. By utilizing very small particles or small size sample is required, and small column diameter. So due to the column diameter is small, so that's why it becomes uh, very fast as compared to the traditional LC, and very high fluid pressure. So these factors influence the advanced performance or advanced facilities in HPLC than your traditional liquid chromatography. So that are sample very small particles, small column diameter, and very high fluid pressure. So this is one schematic diagram of your HPLC. So this is the solvent reservoir. So through this capillary, the solvent is flow through this capillary tube, which is connected to a pump, and after the pumping from of the solvent particles from the reservoir chamber, it was pumped up to the column, and there is one additional, or there is one sampling chamber is there, yeah, at which the sample is injected, and with solvent it is go up to the capillary, and after the separation it is detected by the detector, which may be your UV, FTIR, or any other detector type we will discuss. And then after detector's detection, it will be recorded at the art recorder part, that is mostly the computers. So the computer gives different type of peaks or bands with respect to the different components separated from a mixture, and this pump plays an important role because it creates pressure which uh, which brings an unique mechanism to HPLC by enhancing the separation rate or flow solvent to the capillary. Then the stationary phase and the mobile phase, again the same um, mechanism applies here. That is stationary phase, it is the static phase, or we can say it is the solid phase of the chromatogram of HPLC. Then in stationary phase, the ingredients or the materials to be used are polar. If it is polar, it is known as a normal phase, and it may be silica or alumina. So silica is nothing but SiO2, and alumina is Al2O3, aluminum oxide. Then if it is non-polar, that is known as the reverse polar or reversed phase. It is octadecyl silica. In short, it is ODS silica gel, and some isotope of C18 and C8. It is also there. In the mobile phase, we have in normal chromatography, we have hexane, dichloromethane, isopropanol, methanol. So this will in increasing order of their strength from non-polar to polar, because hexane and methanol is more polar than hexane. So in the right hand direction, the polarity increases. So the strength also increases. In the reverse order, it will be water, methanol, acetonitrile, and tetrahydrofuran. So in the forward direction or right hand side direction, the polarity downs, it is non-polar. So this is your reverse phase chromatography. That is the polar part at the is having the least priority, and the non-polar part having the highest priority. Different components of HPLC, different components or the different parts of HPLC instrument are reservoir, that is a solvent reservoir, followed by connection of with pumps. Then the sample injection chamber is there. Then the column at which the components are separated. It is the column. Then after passing through the column, the sample is now detected, or different components from the sample are detected with the help of detector. And after detector, it is the data processing of your recorder system. Then after recorder system, we have the HPLC peak, and if any waste or impurities are there, these will also can be separated. And the first one is solvent reservoir. The solvent reservoir is treated as the mobile phase. It is isocratic in solution, that is same composition, isocratic, single solvent separation technique. Then we have gradient diffusion, two or more solvents vary during separation. This is gradient distribution to carry sample into the column. So these things are there in your solvent reservoir part to carry sample into the column, that is with the help of a pump. So what is pump? To produce an appropriate pressure. Just wait. Hello? Hello? So then we have the second one, that is the pump system in our HPLC machine or instrument. It will produce an appropriate pressure to push solvent into the sample. It is the role of the pump to generate the required pressure to push the solvent into the sample. A pump capable of pumping solvent up to a pressure of 4,000 psi and at flows of up to 10 milliliter per minute. This is the some standard data for a standard pump in HPLC. Sample injection system, it will have a sample valve or syringe injector. So the two parts are there, two things are there in sample injection system. It is a valve is there at which the sample is injected, and syringe and injectors are there by which the samples are injected. So it is the location and it is the apparatus. So the syringe, it may be manual or auto injector. So two types of syringes are there. If it is manual, then it may be of micro syringe, and if it is auto injector, so this is an inbuilt system in the advanced HPLC machine. A fixed volume loop of between 1 to 200 microliter, 20 microliter is often used as a standard. So this is the standard volume loop which is very much fixed in the sample injection system. Column, that this is where the stationary phase is imparted. So it is a straight one with 15 to 150 centimeter of length and 2 to 3 millimeter in internal diameter. So it is 2 to 3 millimeter of diameter, then 15 to 150 centimeter of length. So packing, the column is packed with either silica gel or alumina, or we can say it is silicate. The different detectors used to detect the separated component of a mixture. The first one is UV visible detector, refractive index detector, fluorescence detector, evaporative light scattering detector, mass spectrometry detector, diode array detector. So there are many types of detectors which are connected to the connected to your HPLC to detect the separated component in a mixture. Then how the data is processed, it is the role of the recorder now. So using specific software that is connected to HPLC machine, so there is a specific software is there. So receive the information from HPLC machine and present it as a graph. This is done with the help of some advanced application or some softwares that are related to your HPLC phenomena. Then the graph describes about qualitative data, that is retention time, and quantitative data, that is from the area under curve. So retention time and your area under curve, this can be predicted from the graph or the plot which are given by the recorder. What is the application? It is to control the drug stability. It is a pharmaceutical application to control of drug determination from pharmaceutical doses. Example, paracetamol determination in Panadol tablet, quantity of drug determination from biological fluid, that is blood glucose level, that is the sugar level, analysis of natural contaminants, that is phenol and mercury from seawater, forensic test, determination of steroid in blood, urine and sweat, determination of psychotropic drug in plasma. So there is some forensic test. In clinical test, we have monitoring of hepatic cirrhosis patient through aquaporin 2 in the nature, in the urine. Food and essence manufacture, sweetener analysis in the fruit juice, preservative analysis in sauces. The factors which influence the HPLC performance. What are the factors that influence the performance of HPLC? This is internal diameter of the column, which is in standard HPLC it is 2 to 5 millimeter. So the diameter of the column influence the performance of the HPLC. Smaller the diameter, higher is the sensitivity, because there will be faster flow of the solvent or the mobile phase. So the interpretation or the calibration becomes faster. Then the pump pressure, higher the pressure, higher is the separation. When the pump is okay, or it creates a constant or a higher pressure than it was applied, then your performance will be better. Then the sample size should be small. So when the sample size also determines the speed or performance of your HPLC. Then polarity of the sample, solvent, and the column packaging. Then temperature, higher temperature, higher is the separation. This is directly proportional. The advantages are we need a small sample with a high accuracy and precision, non-destructive sample using during operation compared to gas chromatography. This is also non-destructive type. What are the disadvantages? Need a skill man to run the instrument. Then the second one is it is highly solvent consuming apparatus. So these are some HPLC data with some graphical representation, that is absorbance at 220 nanometer. Absorbance at 220 nanometer. Then we have with your time in minute. So these graphs of some samples are highlighted here. Then the samples are highlighted of your codeine, morphine, ethyl morphine, heparin, benzyl morphine, uh, normorphine. So these things are characterized with HPLC. Retention time. So the retention time of a solute is taken as the elapsed time between the time of injection of the solute and the time of elution of the peak maximum of that solute. So retention time is the time gap that is from the starting point, that is the sample injection, to the ending point, that is the elution part. So where the component is separated and where we put our sample. So the time gap is known as retention time. So this PPT is up to this. Then we will move to this one where we left that day. So these are very much understood. Then instrument part is over now. Then in the instrument part, just see here. So this is the solvent reservoir, and your solvent reservoir is here, which is connected to the pump. Your rate is connected to the pump, that is this is the pump connection. Then the sample application syringe is here, which is connected to the column, detector, and the recorder. So the same pictorial demonstration is here. Then this is already covered. Then we have the column tubing material and its uses. Some column tube, tubing materials such as stainless steel, polyether ketone, Tefgel, titanium. So what are the different uses? These are highlighted here. Then we have the packing material of our stationary phase. So this is nothing but your silica and alumina. Silica is acidic and alumina is basic one. So depending upon the type of component to be separated from a mixture, the different packaging materials are used to pack the column of our HPLC, that is high performance liquid chromatography. Then we have the silica. This is the version Corasil and Vedak. The particle sizes are given here, and it is a microporous. Then this is the bonded spherical phase, irregular large porous phase, pellicular particle bead, that is pellicular means with different dimensions. Then we have the porous microparticle, that is the smallest one. Then depending upon the various size of the particle of the packaging material, so there is spherical bonded phase is there, porous layer beads are there, porous particles are there, and we have macroporous particles. So just see here, if I go for the adsorption phenomena of different HPLC techniques, that is an illustration was given where different topography are obtained depending on nature of the ligand. Ligand means it may be the solvent or the mixture that is to be separated. It may be noted that different packing materials are used in different type of technique of adsorption, partition, ion exchange, size exclusion chromatography. So these four phenomena or four mechanisms are can be applied on the basis of the component to be separated from a mixture. So the first one is our type of bonded phase, that is the first one is the monolayer, that is the adsorption one. It is the cross link layer here. It is a multi-layer phenomena, and it is the coating one. So the column A is nothing but the bonded phases. Column B is a topography of ligand, that is it is a dense one, diluted one, controlled spacing, and it is also the coating one. Then the third one is the size of the ligand, how the ligand size will have a different packaging, that is the short ligand, long ligand, bulky ligand, and large ligand. Now, these are some pictorial form of your type of ligand to be used as the packaging material. Then different phenomena, that is adsorption chromatography. So in adsorption chromatography, we have the phenomenon of adsorption where the surface of the stationary phase is treated as the adsorbent, and the particles of the sample are known as the particles of the sample are known as the adsorbate particles, which gets adsorbed on the surface of the adsorbent. So we have the surface packing materials. It is generally silica column packaging material, which contain silanol, siloxane bond, SiO linkage, and hydrogen bond, that is SiOHO. So these three types of bonding are there, and if I go for just here, just see, this is the hydrogen bonding, that is between oxygen and hydrogen. This is hydrogen bonding, and we have siloxane bond between this is your silicon oxygen silicon bond. So this is a siloxane type, and we have the silanol free groups are also there. So if I go for the reactivity, the bound siloxane will be less reactive than free, which is less reactive than hydrogen bond. Then we have partition chromatography, where this one, that is the liquid chromatography phenomena, here it is applied. So when the mobile and the stationary phase both are liquid, then the partition mechanism is supposed to be applied. So in partition chromatography, we have organochlorosilane molecules, which is used as the stationary phase, and it is coated with an inert supporting material. It may be silica or alumina or activated charcoal. Then for the preparation of organochlorosilane, it is SiOS, that is silanol with trialkyl silanol chloride, Then removal of hydrochloric acid will form this compound, and on reaction with further groups, it will form a cross-linked structure. This is nothing but your organochlorosilane. Just remember, in organochlorosilane, each that is each terminal silicon atom will have one chlorine group. So this is known as organochlorosilane. Then we have relationship between polarity of the sample with that of packing material and the two mobile phase in reverse phase HPLC. Then we have carbon 18, carbon 8, and the C bonded carbon 2. If the first one is there, column packaging with carbon 18, then we have low moderate polarity, which is soluble in aliphatic hydrocarbons, methanol or water. This is moderate polarity, that is C8, soluble in methyl ketone, and this is acetonitrile or water, mobile phase. And if the sample is high polar, then it is bonded to carbon 12, then it is 1,4-dioxane water. In commercial normal phase bonded packaging, the R in the siloxane structure is a polar functional group such as cyano. So just read out these things. What are the different type of functional groups generally used in your siloxane? In ion exchange chromatography, this is already discussed in the previous classes. In ion exchange chromatography, this is generally used for the separation of ionic compounds or ionic groups from a mixture. So if I integrate the ion exchange mechanism to HPLC, so this is known as ion exchange HPLC. So we have a various structures of ion exchange packaging will be peculiar with ion exchange film is there. Number one, number A, number B is exchanger bead coated with superficially with porous resin. This is number B. This is porous resin is there. The third one is micro reticular bead. Number four is anion exchanger surface sulfonated and bonded with electrostatically. So these are some packaging materials in our HPLC ion exchange chromatography. So during preparation of ion exchanger by silidation, a vinyl group is chosen for R3 in SiO, Si, R1, R2, R3 compound leading to vinylated silica. So one vinyl group is generally chosen. This is the vinyl group, that is CH11CH2. When reacts with styrene, we have this polymeric chain. So when this polymeric chain undergoes some reaction, it's some chain reaction, we have two types of ion exchangers, that is a weak anion exchanger and strong anion exchanger. The strong anion exchanger is with your benzyl chloride, and weak anion exchanger is with your RNH2. So then size exclusion chromatography, as we know, the beads which are used in size exclusion chromatography for packaging have some micropores which feeds to the smallest particles of the mixture to be separated, and the bigger particle of the mixture will are excluded for their accommodation in the bead. So due to this chromatography is also known as size exclusion chromatography, where big size particles are excluded from the from the adjustment to the beads pore of the beads. Then we have some pore size diameter with operating range in Dalton. So just go through these. Then we have the same thing, that is type of commercial packaging for size exclusion. polystyrene diphenyl benzene, particle size 10 micromolar, average pore and molecular weight exclusion limit. So next one is silica. Then ion chromatography we have. It is little bit different from ion exchange chromatography in the nature of exchange resin. So ion exchange chromatography and ion chromatography, this is of a different type. So here the nature of exchange of resin is different. The technique involves an ion exchange column and a means of suppressing ion species other than the sample ion in the eluting mobile phase to facilitate detection of the sample by conductivity monitor as demonstrated. So here this is the reservoir, this is the pump, and here the sample is ejected. So this is a delivery mode, and here the separation column is here. So when there is separation, it will be surprise that is detected by the suppressor, and now it is in the conductivity cell, and with the application of some electrical power or electrical energy, we have the required separation of the components in a mixture. So after the chiral chromatography, and in chiral chromatography, what happened? The packaging material is a chiral organic compound. So what is chiral or chiral organic compound? Uh, in an organic compound, a carbon is said to be chiral when it is bonded to four different groups. If a carbon is tetrahedrally bonded to four different groups, that carbon is treated as a chiral carbon. So here for chiral chromatography, what happened? The stationary phase or the column is packed. The stationary phase or the column is packed with some chiral compounds. Here it is written, that is CSP, that is chiral stationary phase, is based on the formation of transient diastereomeric compound between the enantiomorphs of the solute and the chiral selector, which is an integral part of the stationary phase. So here chirality is maintained. So illustration of tertiary complex formed between an L-proline bonded phase and an analyte amino acid and a copper 2 plus ion. So this is one of the ternary complex formed in by using the chiral phenomena. Then the cyclodextrin bonded stationary phase have been demonstrated to be particularly efficient in resolving structural isomers. So this chromatography is generally used, that is chiral chromatography, for the separation of enantiomers, diastereomers, epimers, etc. Then we have packing materials here. For what is the mode of HPLC and what are the applications. So if the packing material is microparticulate silica, whether it is spherical or irregular particles, mean particle size is 3, 5 or 10 micromolar, which is chemically modified version of the above packaging, then it is liquid solid chromatography, which involve the adsorption phenomena. The examples are non-polar to moderately polar mixture, example polyaromatics, fats, etc. If I go for ODS, that is octadecyl, then the bonded phase and ion pair chromatography mechanism or mode of operation will apply. Then wide range of moderately polar mixtures or pharmaceutical mixture can be analyzed. If I go for C8, that is only octyl, then it will be your bonded phase chromatography or ion pair chromatography, and these are some examples, that is pesticide, herbicide, peptides, etc. Then other your other packaging materials are given here. Let's go through these things, and these are all your include your chiral peptides. For chiral peptides, it is mixture of enantiomers, specially of drugs. So after that, it is your solvent supply system, that is the reservoir part. Nature and composition of the mobile phase in liquid chromatography plays an important role as it provides a dimension in terms of retention time for experimental manipulation. In case of high performance liquid chromatography, high purity solvent without any dissolved gases should be used because any impurity may affect the retention time. So the solvent which is used as the mobile phase in high performance liquid chromatography should be chemically inert, and it must mostly react with all the solutes available. So in that sense, this solvent should be selected. So and this mobile phase, that is the solvent, should not react with the react with our solid phase, that is the stationary phase. So it should dissolve the sample. So this is the first point. It should keep the column stable. That means it must not react with the column. It should be compatible with the detector. It should be immiscible with the stationary phase. Its viscosity should not be high, and the last one is active fluoride should be avoided when using glass column. So when your mixture containing active fluoride, so it must be removed before HPLC analysis. So then one term is there, that is the eluting power of a solvent is determined by its overall polarity, the polarity of the stationary phase and nature of the sample component. The capacity factor K dash is controlled by the strength of the solvent, which can be easily predicted in adsorption chromatography. So then we have some solvent with this adsorption chromatography, that is the strength of the solvent. We have some physical properties. Solvent strength parameters are given here with viscosity and effective index. When we have gradient illusions, that is a highlighted part. It involves continuous change in composition of the mobile phase by allowing a more polar solvent to flow into the reservoir containing a less polar one, whereas the mixture flow to the column, that is like your 8.12 depiction. That's a complex mixture of solute that cannot be separated by isocratic separation, can be separated by gradient illusion. So when the isocratic separation, that is one solvent separation, is not applicable, then the mode will be changed and there is gradient illusion will be there. So this is three types of solvent reservoirs are here. So depending upon the components with multiple valve here. So as far as our requirement is concerned, these multiple solvent reservoirs are accordingly used. So this is known as gradient illusion. Then we have pump. I will just skip this one. So this is the pump. So the type of pump is a reciprocating piston pump. So these are some specifications. Just try to remember these things. This is uh, the it consists of a small motor driven piston moving rapidly back and forth in a hydrolytic chamber that may vary from 35 to 400 microliter. This is a reciprocating piston pump. Another pump is there which is syringe type displacement pump. These pumps work through positive solvent displacement by mechanically driven piston at a constant flow rate. The piston is actuated by a screw-fed drive through a gearbox usually run by a digital stepping motor. The rate of solvent delivery is controlled by changing the voltage of the motor. So these are some capacity and your pressure capability of your series type displacement pump, which is further moved to your constant pressure pump. So just I try to remember the various datas in constant pressure pump. That is, solvent is proportional to the ratio of the area of the two pistons in between 30 is to 1 to 50 is to 1 ratio. And here generate of the liquid pressure of 1 to 400 atmosphere. In a pneumatic pump are here. These type of pumps are simple, inexpensive and pulse free, but suffer from limited capacity and pressure output. In this case, mobile phase is contained on a collapsible container housed in a vessel that can be pressurized by a compressed gas. These are not amenable to gradient illusion. Then we have the detector part. So detector already we have discussed in the PowerPoint presentation. So in detector that must be selected accordingly based on the type of component to be separated from a mixture. The single most crucial factor in is continuous detection based on the progress of separation of a component. That is, a good detector must have a linear response to solute concentration in range 0.1 gram liter to 1 nanogram per liter. It should respond to solute only and not to the solvent or change in solute to the solvent ratio. That is that mm, the detector must emphasizes on the the remarks of the detector. Then we have it should respond to solute only and not to the solvent. This is very important. It must not react with the or respond to the mobile phase. It should be insensitive to change in temperature, pressure, and flow rate. Then different type of motors: bulky property motor and solute property motor. So bulk property motor and detectors. These type of detectors measure on overall change in physical property of the mobile phase with and without solute. Example: refractive index, dielectric constant, density, electrical and internal thermal conductivity, vapor pressure, etc. These type of detectors are somewhat insensitive and require good temperature control. So this is all about your bulk property detector, which is nothing but the overall change in physical property. It may include a refractive index, dielectric constant, density, conductivity, vapor pressure, etc. Then a solute property detector, these include your physical property of the solute that is not exhibited by pure mobile phase. These are highly sensitive with sorry wait these are highly sensitive with a detection signal for a few nanogram or even lesser amount of the sample. For example, absorbance, fluorescence, diffusion current, etc. can be considered. So besides the low detection limit, HPLC must meet the following. What are the conditions? Number one is selective response towards one or more classes of solutes. That means when a mixture contain one or more class of solute, then the HPLC must selectively respond. It must be small and compatible with liquid flow. It should be small and compatible. It should have good stability and reproducibility. It must have low dead volume to minimize extra column band broadening. It must have high reliability and ease of use. It must have small response time at least 10 times less than the peak width of a solute. It should have a linear response to solute that extends over several order of magnitude. So these are some basic needs of a HPLC detector. Then we have performance of some SPLC detector, that is detector property are there. A typical LOD in mass, the linear range and commercial availability data is given here. Then optical detector, this is the third category. So these optical detectors include your spectroscopic measurement. So here the first measurement is by ultraviolet detector. The second was is by your deuterium lamp and scanning wavelength detector. So in UV visible instrument, what happened? In UV visible, the components to be separated are placed by the use of a cuvette and against a standard demineralized water. So for standard demineralized water, there will be no observance of lambda max, but for your sample, the UV will be illuminated with distinct color and with some positive value of your lambda max. Then we have some mathematical calculations are here. Just go through these things. Then we have fixed wavelength detector under your UV, that is wavelength is fixed. That means observance, the variation will be the observance. Then variable wavelength detector means it is the difference in wavelengths under different conditions or the type of sample to be analyzed or separated. So under fixed wavelength detector, we can read out that it uses a light source that emits maximum light intensity at one or more discrete wavelengths that are isolated by appropriate filters. These have minimum noise but no free choice. Then we have a medium pressure mercury lamp can be selected for wavelength of 254, that is a lambda max, 280, 313, 334 and 365 nanometer by the use of narrow band pass interface filter. Then variable, we have the range of wavelength are possible in one detector, that is known as variable wavelength detector. It is usually a wide band pass UV visible spectrophotometer coupled to a chromatographic system. So this is the chromatographic system. Then by the use of some spectroscopic technique or spectrophotometric technique, we can be analyze the components. Scanning wavelength detector. So wavelength is scanned solid state diode array are used to record spectrum for each solute simultaneously, monitoring all wavelengths. Thus, a complete spectrum for 190 to 600 nanometers can be obtained in just 0.01 second. Some instruments can be configured or scanning complete spectrum for monitoring of independent signals. All the signals can be integrated between two preset wavelengths and thus multi-component complex sample can be detected. So this is all about your scanning wavelength detector. Then infrared observance detector, where IR light is used for observance of different functional groups present in the component of a mixture. So here what happen? Yeah, if your sample is a solid sample, then a pellet is prepared with your KBr, that is potassium bromide pellet is prepared, and that pellet is placed on the surface of the sampling chamber to have your technical data that is related to your IR observance. So in IR observance, we will measure two types of things. that is your stretching frequency and bending frequency. So different organic functional groups have different stretching and bending frequencies. So the from the data of the stretching frequency and bending frequency, the um, uh, stretching frequency and bending frequency, the presence of different functional groups in a component of a mixture can be predicted easily, and the range of that IR wavelength, the wavelength is around 4000 to 690 centimeter inverse. This is the range, or we have 2.5 to 14.5 micrometer. Then the second type of IR detector is based upon Fourier transform, that is also in short it is known as FTIR, that is Fourier transform infrared instrument, is also nowadays is integrated with our SPLC to have a better analysis. Then fluorescence detector, we will excited the ground state electron to higher excited state electron, and that electron will comes back to its original state by reflecting the energy it gained, and through that energy we can have fluorescence effect or phosphorescence effect. So this is very beautifully explained in your Jablonski diagram, that is in your photochemistry part. Then differential refractometer, that is it monitors the difference in refractive indexes between reference and the column element. Reference is our mobile phase and the column elements are our sample. So this monitor the difference in refractive index. So this is differential refractometer. So this is the setup, that is sample, mirror, lens, mask, then it is a light source, recorder, amplifier, then it's a transducer, optical zero, references. So these things are there in your differential refractometers. The same mechanism uh, applies here after the separation of the component. After the separation of the component, this refractometer then start its work to detect the exact composition or exact property of the separated component. Electrochemical detector, where after separation of the component is detected electrically or electrochemically. So this is an amphoteric thin layer detector for HPLC. This is a use of the electricity, the detection of the component, that is separated component, is done. Then we have some examples, a working electrode. Here it is platinum, gold, glassy carbon, etc. Then just for what is the cell volume, that is 1 to 5 microliter. Then usually the electrodes are silver chloride electrode, that is a neutral electrode, a reference electrode, which are used here. So then mass spectrometric method. So mass spectrometric. So here spectrophotometric is not applicable for your mass spectrometry, because in UV visible IR, NMR, this type of spectroscopy, we have used the electromagnetic radiations. For UV visible, it is UV. For IR, it is IR. For NMR, it is radio wave. But when we go for the mass spectroscopy, so for mass, this is not spectroscopy, this is spectrometry, because in mass spectrometry, the excited energy which is there to change the energy state of the electron, it is nothing but the high speed electron. This is not an electromagnetic radiation. This is the energy of the electron, which is having very high energy, and that high energy electron will bombard to the nucleus of an atom, which gets splitted into small fragments. So this is mass spectrometric detector. So when the components are separated, this mass spectrometry is connected, and by fragmentation, the components are detected. And when it is integrated to liquid chromatography, the instrument is named as liquid chromatography mass spectroscopy. Uh, and the advanced version, that is the gas chromatography mass spectroscopy GCMS, it is mostly used in various satellites, or your um, astronomical analysis. So these things are done by this GCMS or LCMS type instrument. Then there is comparison. Just read out these things. Then we have the next part, that is optimization of separation. So how? So these are some solvents or the mobile phases that are used in different percentage. Here it is methanol, tetrahydrofuran, and water in different percentage, and how the compounds like your benzyl alcohol, phenol, 3-phenyl propanol, 2,4-dimethyl-phenol, benzene, diethyl orthophthalate. So how the change in concentration of the different mobile phases, that is combination of mobile phases, the graphs or the plots are differing. So by the from this number, you can predict the which one is your compound. Just read out these things. Then we have methyl, octyl, and octadecyl, that is ODS. This is silica gel. Number one is your uracil, phenol, acetophenone, nitrobenzene, methyl benzoate, and toluene. These are all collected from different research articles. Then these things is not needed to remember by you from your examination point of view. So then it comes, that is the advantages. So what are the different advantages of HPLC over gas chromatography or liquid chromatography or all other chromatographic methods? It is very fast separation method with analysis time as small as less than a minute. Very fast. Less than a minute it can be analyzed, or it can separate the components. It is useful for separation method with high resolving power, and a quantitative analysis method with low detection limit and high accuracy. Now this having high accuracy, this is having high resolution resolving power, and a quantitative analysis method is also applied. But the low limit is very low, that is low detection limit. It is especially useful for resolving optically active compounds, though different types of columns with chiral stationary phases are used. So optically active compounds means these are diastereomers or enantiomers. So these optically active compounds can be detected by using chiral stationary phase, that is chiral chromatography. The technique is applicable to small amount of sample when where even trace amount of solutes may be determined. So when small amount of samples are there, this technique is applicable. All kind of solids soluble in suitable organic solvent and liquid sample can be analyzed through, though gases cannot be analyzed. So the one limitations we have detected now, that is gases cannot be analyzed through HPLC. HPLC has much wider applicability in pharmaceutical and food processing industry, including forensic and environmental samples, compared to gas chromatography, which has been found to be more useful in petroleum industry. It is followed by, it is especially useful for continuous monitoring of the column effluent, and thus it can be used for any online process where analytical precision may be automated and data not be handled manually. It provide repetitive and reproducible analysis using the same column. It is being widely used for the speciation of ionic and non-ionic species, such as various organic and inorganic forms of arsenic. It is more versatile than gas chromatography since it is not limited to volatile and thermally stable samples. With wider choice of stationary and mobile phases, it is a non-destructive important. It is a non-destructive method which can be used for preparative and process scale separation. It can be used for the separation of closely related compounds as well as for the purification of the compound. There are various advantages, so there are few disadvantages are there. It can be used only for volatile compounds such as hydrocarbons. It cannot be used for the analysis of industrial products such as alloy, polymer, etc. High purity solvents are required because an impurity may affect the separation resolution. So the solvent should be at GR grade. So this is a limitation or disadvantages. It requires extensive training in order to operate the instrument. Sample preparation is often required that involve a dissolution and dilution. So these are the some advantages and disadvantages of your HPLC, followed by our comparison with the gas chromatography. So gas chromatography, we can easily separate the gaseous having low boiling point. Liquid solute can be analyzed. For HPLC, it used to separate volatile and non-volatile, including soluble inorganic solvents. So this separates gas having low boiling point, but HPLC can separate volatile and non-volatile mixtures. The amount of sample required in gas chromatography is of the order of few nanogram per milliliter, whereas for HPLC it is microliter. It is even a fraction of microliter may be sufficient. In both the cases, the sample is introduced using a micro syringe. The column tubing, this is very important question from examination point of view. That is the similarities and dissimilarities between HPLC and GC. So how HPLC and GC methodology or mechanism are having some similarity points and dissimilarity points. The instrument setup in two cases are widely different. In GC, it is essential to have some sample injection chamber, column and detector also housed in a thermostated oven, and an inert gas carrier is used. On the other hand, in HPLC, quite often a mixture of high purity solvent of low pressure gradient is used. For HPLC, though detectors are common, but not all the detector used can be used by another. So FID or ECD commonly used in GC but cannot be used in HPLC. So this is the detector's point of view. So how the GC and HPLC are same or different. The optimization of experimental procedure in GC is easier, whereas in case of HPLC it is difficult. The optimization. The basic mechanism of separation in GC. The basic mechanism of separation in GC is adsorption or partition, whereas in HPLC it may be adsorption, partition, ion exchange, or size exclusion, etc. GC has limited applicability for gaseous solute only, though it is useful for the identification of hydrocarbons of a homologous series. On the other hand, HPLC has much wider applicability to a variety of organic and inorganic compounds. GC cannot be used for separation of ionic species, whereas HPLC can. So these are some similarity and dissimilarity between GC and HPLC. Then various applications. If the solute, that is the component to be separated, if it has a molecular weight less than 2000, the separation procedure is little bit different. then it is molecular weight greater than 2000. So let's start with that greater than 2000. So if the molecular weight of the component is greater than 2000, then it may be a synthetic polymer or a biopolymer. If it is a synthetic polymer, then the process of size exclusion chromatography will be applicable. So for biopolymers with molecular weight greater than 2000, the size exclusion with size exclusion chromatography, two additional chromatography techniques can be adopted, that is reverse phase chromatography, that is non-polar becomes polar and polar becomes non-polar type, and hydrophobic interaction chromatography, where we have the absence of water or absence of aqua ligand, the chromatography technique is carried out. So this is for your solute with molecular weight greater than 2000. If it is less than 2000, then it would have your ionic, ionizable, non-ionizable, and the second part will be soluble in organic solvent. It will be methanol or hexane. So two type of solvents are highlighted here under your organic solvent solubility. So under inorganic part, that is the ionic part, the ion exchange chromatography, it can be applied for ionizable, that is acid and bases. It is ionized form and non-ionized form. For ionized form, again the ion exchange chromatography. If it is ion pair, then a reverse phase chromatography is applied. Then if it is non-ionized form, in the second part, that is ion suppression will be there, and we have the same thing, that is reverse phase chromatography. Then for non-ionizable, again the reverse phase with hydrocarbon phases. Here it is the polar phase. For methanol, again the reverse phase, and this is the reverse phase with the polar, normal phase chromatography, and normal phase chromatography with silica and alumina. Then for the same thing, it is the hexane one. So this is the your application of your, or how to choose, how to select which chromatography is more or less applicable to your sample. Then we have some applications in pharmaceutical, biochemical, food, industrial, clinical, polymer, forensic, pollutants, and quality control. You just read out these things. Then polyaromatic hydrocarbons are there with this type of HPLC plot. The first one is for naphthalene. This is fluorine. This is phenanthrene, anthracene, and pyrene. Using spherical porous and spherical silica as the stationary phase. Then we have isomeric compounds are there. Like this, that is seen an antiposition pyrazolines with the same molecular weight and same molecular formula, only the configuration is different, that is one is seen and one is another is anti, also known as cis and trans. So how these cis and trans will affect or will have the HPLC data. Then sugar in popular drinks, it is predicted here. Then we have, this is the sugar label in orange, cranberry, apple, pineapple, and in standards. Then drug abuse, these are some drugs with their HPLC layout. Then separation of nucleic acid also here, that is A is AGPAX cation exchange packaging using HPLC. B is conventional ion exchange chromatography for the separation of different nucleic acid like cytosine, adenine, guanine, and uracil in your It is, this is your separation of the amino acids. Then analysis of amino acids are there using HPLC, and some amino acids are analyzed using HPLC and how their peaks are differing from one another. And partition chromatography is also, that is liquid chromatography. Partition chromatography is there for different organic samples. This is dimethyl, diethyl, dipropyl, dibutyl, dipentyl, dihexyl, diheptyl, dioctyl. So these compounds are separated of your ortho phthalate ester. Then we have vitamin C, saccharin, caffeine, sodium benzoate. Then we have methyl parathione, pseudoerythrin parathione. These are some pharmaceutical compounds or organophosphate insecticides. Then it is ion chromatography application. So this is your ions are to be separated. Then we have the reaction of your carboxylate group with your quaternary salt, quaternary ammonium salt to form a ion pair, which is nothing but a Jeter ion formation is there. So by formation of this ion, the components get separated. Then we have the compounds like niacinamide, pyridoxine, riboflavin, thiamine. Then chiral separation of enantiomers. This is an optically active compound are separated using chiral separation. Then ion exclusion chromatography is there. Then we have speciation studies. It has been well emphasized in the preceding discussion that HPLC can be successfully used for the separation of a wide variety of ionic, non-ionic, and polar compounds. It, in many cases, such as arsenic, selenium, mercury, and organic forms, are formed. Their detection is very difficult because of occurrence in very low concentration in the environmental samples. In this case, the speciation studies have been carried out with 4 species, that's the arsenic 3 and 5, organic species such as monomethyl arsine and dimethyl arsine, and arsenochlorine. So then with the interfacing HPLC with mass spectroscopy, that is your HPLC MS. This is a very advanced version of your HPLC to detect the unknown component in a mixture, and in very few in very short time of period. The analysis is very fast. Then thermospray method are here. By application of heat, there will be a spray like mechanism will be there. So this is thermal generation of spray and separated heat treatment of that spray to yield desolvated ions. The temperature maintained is 400 degrees centigrade. So then particle beam interface, atmospheric pressure, chemical ionization. Just read out these things. Many things are here. Electro spray interface, the same thing is here. Then moving belt interface. At the end, it will have the summary. So this is a very large or vast topic of chromatography is there. Just in this part, you just read the instrumentation of HPLC, principle of HPLC, how and different detectors, different pumps which are used for their detection or mechanism in HPLC, followed by the similarity and dissimilarity with gas chromatography, and and disadvantages and advantages and disadvantages of your advantages and disadvantages of your high performance liquid chromatography. So just try to read out these four things from this unit, and I am sure that from these four you will get questions for your examination, and these things are not needed for your examination point of view. Okay, so these are some application part, and after this we have some time for our discussion. If anyone or having any query or something to add or something to say, now the platform is open. Any query from our previous units or related to your program or anything else, now you are mm, so now the forum is open to all. So up to you students now. So any clarification or any doubt you wish to clarify, or anything else you wish to add? So today I will share all the your PPTs to your WhatsApp group. Then after that you just always I forgot. Okay, Swarnamay Pradhan, put your mobile number here. Put your mobile number here, and I think your group admin is. I am not the admin, but I I can forward your number to that group to add you to that WhatsApp group PGDSC 2023. So may I know who is the admin of that WhatsApp group?
Hello.
Yes, yes, right. Yes, Raut is the admin.
Yes, sir. I will add that number.
Okay, okay, okay. So you just add Swarnamai, Avinash, Kedar.
Kedar. Sure,
See,
sir.
this
Those
is
who
this
are
is
sharing their
this is
number,
not.
I will add them.
Yes, 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 yes. Just take one photo of this.
I will take the screenshot, sir. Screen.
Yes, yes, yes. Take the screenshot.
Okay.
So I am just sharing all the PPTs.
Yes, sir.
Yes, sir. Please, sir.
Actually, I yesterday forgot to PGDSC. Which one is yours? This one. I think this is not the way. PGDSC. This one, I think, na? Ignore PGDSC.
Sir, I am sharing you one screenshot.
I think this is the group. Yes, yes, this is the group. I am just sharing, and yes, you first add the.
Yes, sir.
You just you just first add the students, then I will share.
Yes, sir. After the
Then
class, I will add them.
okay, okay, okay.
Okay.
This is the
Just one.
separation technique. So any queries, students,
Sir.
or everything is went so smoothly that you can write your answers in your exam. So if you understand the basic things of your separation technique, then everything is more or less easy. I share this one also. This is your HPLC and gas chromatography. Block 3 is event, block 4 ion exchange and size exclusion. Then this is your block 4. Then from block 5 it is membrane separation and electrophoresis. These two. And we have membrane separation and electrophoresis, and from so up to this I think. So these are the things I have as a PowerPoint presentation from this paper, and I also have a good experience with you students that patiently you have listened all the things I have said and shared with you, and in some parts we moved so quickly because that units have to be covered within 1 hour. So as the time limit is there, so some theoretical mathematical aspects we have skipped, and the things we have highlighted or discussed in our discussion, you just emphasize on that part of that topic or unit, and I am very much confident that from that part only we will have your questions for your examination. And anyone having any doubt, or we may wind up our session. It is 6:30 now. We may have 10 to 15 minutes of interaction on anything you wish to ask related to your this paper or anything else related to your program, your practicals, or anything else. Swarnamai, then Avinash, yes. Yes, Raut, just mute
Yes,
your,
sir. Yes, sir.
just
I just
mute.
want to say
Yes, yes.
till now I have not gone through the subject chapter wise. After some days, when if you find any doubt, then I will call you, sir, personally. Otherwise, in group.
Okay, okay, okay. You can. It's no problem,
Yes,
no
sir.
problem. Just students, just try to understand the basic mechanism or the principle involved in different separation techniques and the chromatographic mechanism. If you understand the things, then just remember in almost all the chromatographic methods, the stationary phase is more or less same. That is, it is prepared by silica gel or alumina, except the liquid chromatography. Where liquid chromatography, it is the column chromatography, which is three-dimensional, and for your paper chromatography, it is an ordinary filter paper. For thin layer chromatography, it is the TLC plate. For ion exchange chromatography, it is the ion exchange resin. For membrane separation, it is mostly the semi-permeable membrane, or depending upon your component. For electrophoresis, it is the gel permeation. So just try to remember the stationary phase, the mobile phase, and the principle or the mechanism involved in that separation. And in if your stationary phase is solid phase, just close your eyes, and the mechanism involved is adsorption. If your stationary phase is a solid phase, the adsorption phenomena is applied. If your stationary phase is a liquid phase, it is coated with a supportive inert material, which is and the mechanism involved is your partition, the liquid partition. Just try to remember these things. Everything you can write in your own words, and do not try to remember all the huge syllabus or huge materials. It is not possible to carry out all the things to your examination hall. And the questions or the things which I have said to you, the maximum question you have will be from that section only. So anyone, Iyer sir is there, I think. Janardhan Iyer, I think you are willing to say something.
Yes, sir. Yes, sir. Sir, actually, I want to know is what is the difference between the gas chromatography and HPLC? Any
So
any
in
two
gas,
or three?
in gas chromatography, your
Yeah.
mobile phase is a gas, but in
Okay, sir.
HPLC, your mobile phase is liquid.
Okay. Okay.
In gas chromatography, you can separate gaseous particles, but in HPLC, we can separate volatile and non-volatile substances.
Okay, sir.
Okay. So
Okay, sir.
again, the
Sir,
yes, yes.
sorry, a small request. Please, you have add for my WhatsApp number.
So
This number.
you put your number in chat box. Then yes will add you, because yes Raut is the admin of your group.
I don't know which is the chat box, so I just not write down.
So you just say your number. I will type.
95
Yes,
61
yes.
99
99
2713 13.
2713. So just
Yes, sir.
see, I put your number in the chat box.
Okay. Okay.
9561992713.
Yes, sir. Yes, sir. Yes.
Okay, so yes, Raut is requested to add this number. And uh,
Yes,
anyone,
sir.
students? So I think your third paper, your third paper will be, just wait.
गोटे सब पाइदिन अब पाइनଥିଲି
Your third paper, this one, it will be conducted. Yes, this one, on 5th of February, and it will be by Dr. Apramita Chand. And this is very interesting paper is this one, the spectroscopic methods, which involve your UV visible spectroscopy, that is your infrared spectroscopy, IR spectroscopy. NMR spectroscopy is there, that is a nuclear magnetic resonance, followed by your mass spectrometry is there, and with some brainstorming sessions are also there within your in this part. Then at the end we have Dr. Bibhu Prasad Sahu, who will take your MCH-4 paper on 14th Feb 2024, and he will be deal with electroanalytical techniques that involve your potentiometry, conductometry, voltammetry, amperometry, archenotometry. These things are there. So hope you will have lots of things to learn, and you will enjoy the remaining classes of your program. And if no queries or uh, anything that is not there, we may wind up our session, and hopefully we will do well in your examination. And we will meet again in your practical classes or practical examination if it conducted in. So we are planning to conduct your practical classes first after your theory classes are over. So your practical,
Sir,
yes,
Soman.
Yes, Raut, please. Yes, Raut, please mute. Okay, Soman Das.
Sir, please tell me last date of assignment submission.
Actually, your assignment submission is March 31st, I think. It is now, I think, March 15th. Then generally the date is extended. So
Hmm.
you may submit your assignment by 15th of March. It will be okay.
ठीक है वो
So my next is your PGDSC practical classes. So we are planning to conduct your classes in online mode, I think so, because in offline mode it is and now depends on your study center to conduct. So how far they are manage the practical classes, because you have vast practical. I just downloaded your practical uh, things yesterday. Then in your practical part, it is just see, these are the things there in your lab 1, that is MCH-L001 part. This is the you can say this is inorganic practical having credit 2, that is estimation of nickel by dimethyl method gravimetrically, estimation of trine in brass gravimetrically. So this is inorganic practical. Then in your second block of your practical, it is your chromatography. You see, this is thin layer chromatography, column chromatography, then it will be the paper chromatography, and so this is the separation techniques are involved here. Second paper, and in your third paper, it is all about your spectroscopic technique, that is related to your IR spectroscopy, NMR spectroscopy, UV, IR, NMR mass spectroscopy, flame photometric determination. These things are there. So this is related to your spectroscopic methods. And the last one, oh sorry, I shared my screen or not with you? I
no sir
forgot.
no sir.
Oh, sorry. I forgot to share. Just wait. I think now it is shared.
Yes, sir.
Okay, sorry. So in the first paper, is it very visible? This PDF?
Visible.
Okay. So in your MCH-L001 paper, so the experiments involved are basically the inorganic chemistry. So this is generally the gravimetric analysis or your precipitation titration, or iodometrically or iodimetrically, so volumetric and gravimetric both. So this is generally, these practicals are under inorganic practical. Then we have the second paper that is related to your chromatography, that is the separation techniques. So this is your thin layer chromatography, that is number 8. Column chromatography, that is separation of chlorophyll pigments, which are done by Swelt, the first inventor of chromatography, the chlorophyll pigments. Iron aluminum by column chromatography. So this is related to your separation techniques. Then the third one, this is related to spectroscopic methods. So under this part, we will have some spectroscopic analysis using UV spectra, IR spectra, NMR spectra, or mass spectra. So these are all the spectroscopic methods. And if we go for a physical mode of practical classes, then only the UV analysis we can done, because in maximum degree colleges IR and NMR instruments are not there due to these instruments are very expensive. That NMR instrument is around 2 crores. IR instrument is some lakhs, like 20 lakh or 30 lakh rupees. But UV is very cheap, and the maximum colleges have UV spectrophotometer. So if we have this paper practical to do physically, then only UV can be done, and other practicals we may conduct. And the end we have electroanalytical. This is your MCH-4 paper, and this is also your MCH-4 paper theoretical, that is related to your conductometry, potentiometry, pH metry, amperometry, voltammetry. So these things are there. So this will be teach by Dr. Vibhu Prasad. So practical related things or any information will be forwarded to you through your email. Sir, only your PPT in WhatsApp group sufficient for examination. So this is the PPT. You are just read the PPTs for your basic understanding, and you should follow your book, that is the PDF provided by the IGNO, and don't try to read all the things. Try to minimize the application part, advantages and disadvantages part, and also the different type of detectors, pumps, different type of sampling techniques. These things are not required. Only you should remember the principle, principle, then instrumentation, then some application with disadvantages and advantages. That much for every chromatography and every separation technique. So this is more than enough for your examination point of view. Okay, so you should you can follow, follow the PPT, and with that you also have some reading to the PDF, the IGNO PDF. Okay, where assignments notebooks are available. There is no assignment notebooks. Just download the assignment question from the IGNO website, and try to get the answer from your IGNO study material. And one important tips I can share to you, that your PGDSC assignment will have, I think, 10 questions of 10 mark each. So try to write 2 to 3 side of the paper, 1 2 3 maximum, not more than that, for one question. So your total assignment should be minimum of 20 to 25 pages. Then if you write that much, then you will get good mark in assignment. Don't write. I checked various assignments of various programs, and they write 60, 70, 80 pages with they prepare one book for one paper assignment. So it will be it becomes very hectic for us to check all the answers and give marks to that student. So for one question, for 10 mark question, 2 to 2.5 page is more than enough. So you just write the gist, or write the exact theorem or a derivation or any explanation, then you will get the mark. Because assignment is not too tight, or we are just liberal to give you mark. Yes, Raut, you wish to say something?
Yes, sir. सर
Yes.
मैं ये बता रहा था, जो मैकेनिज्म सर आप बताए थे ना सर, एक बार जो रिपीट कर लेंगे क्या सर? वो थोड़ा सुनाई नहीं दे रहा था मुझे सर। जो जीस्ट है ना
मैकेनिज्म
सर
मतलब
क्रोमेटोग्राफी का,
वो हो गया।
वो सर
हाँ हाँ,
जो
वो
मैकेनिज्म यूज
क्रोमेटोग्राफी
हो
में
रहा है,
जो
और
है,
सर क्या क्या सॉलिड और लिक्विड के लिए
जो मैकेनिज्म है वो बस आप टेक्निकली इन
हेलो
जनरल आप याद रखो। यस यस यस, आई एम रिप्लाइंग।
हेलो
Yes, Raut, I am replying. Are you hearing me? So you can call me after the class. Okay.
Sir,
Yeah, Prashant, please.
sir, which year assignment should we write, sir? 2023 or 24?
You should write the assignment 2024 January June, because this is the second semester you have. Actually, you do not have the semester type now.
Yes, sir. No, sir.
You have one exam.
Yes, sir. 1 year only.
Okay, 1 year, right. So, your admission year is 2023 June
July 23.
or July 23. Okay, that is the June session. Okay, though you are you just download the June 2023 assignment.
Okay, sir.
Okay, and 2024 is for your the fresh admission. That is January 2024. So, if no questions are there, yes, Raut again.
हाँ सर, बहुत सा जीस्ट सर फ्रॉम
अभी
जो
सुनाई दे रहा है
चैप्टर।
तो अभी आपको
हाँ
सुनाई
हाँ
दे रहा
सर,
है तो
सुनाई दे। हाँ
ओके।
सर, सुनाई दे
सो
रहा है।
आप एक इन जनरल एक बात याद रखो कि इन
जी सर।
मैक्सिमम chromatographic technique, the
Yes, sir.
stationary phase used is silica gel or alumina. Okay,
Yes, sir.
and when the stationary phase is solid, the mechanism involved is adsorption mechanism. Adsorption.
Yes, sir.
And when liquid sample is used as the mobile phase, or sorry, liquid sample is used as the stationary phase, then what happen? The liquid phase or liquid is coated with a supportive solid material, and the mechanism involved is partition. Okay, and you should
Hmm.
remember, very easy it is to remember. For paper
Yes, sir.
chromatography, for paper chromatography, stationary phase is paper, that is filter paper. For thin layer chromatography, stationary phase is thin layer plate. For liquid chromatography, LSC, it is liquid solid chromatography, it is silica gel or alumina. For liquid chromatography, again the liquid state is coated on a supportive solid material. For gas solid, it is again silica gel. For gas liquid, again the liquid is coated with that supporting solid. For ionic exchange, the some ionic exchange resins are used. It may be cationic exchanger or anionic exchanger. For membrane separation, for osmosis, it is your semi-permeable membrane. For other separation, other membranes are used. For your electrophoresis, your gel permeation, that is the bed is coated with that gel, sampling is done and electrification is on, then the ions are migrated to their respective electrodes or respective ends. So these things are
Yes,
there.
sir.
Just try to have a basic knowledge, then it will help you to memorize the things. Okay.
Yes, sir.
Okay. So thank you,
Thank you.
students. I have mm, very pleased to take your classes for 7 days. And if you have any doubt related to any query, just put a message in WhatsApp group, or you can call me before 9 p.m. That is night. Before 9 p.m. You can call me at any time, and hope you will all do your best and you will have successfully completed this course at your in your first attempt. So thank you to all.
Thank you, sir.
Thank
Thank you,
you.
sir.